We are going to use primary trig ratios, which is SOHCAHTOA, and we're going to solve sides and angles of a triangle, or specifically a right angle triangle. Okay, so we already know that our ratios are SOHCAHTOA, and what we're going to do, is because sometimes it can be hard to tell which one you're going to use, is we're going to set all three up every single time we're trying to find some information, and we'll kind of see by deduction that you can really only use one at a time. So in the very first question, they've given us this. I just made it up. This angle here is 50. This side here is 50. They have now told us they want you to find x, side y, and angle theta or z. Let's just call it z, right? We have our x, y, and angle z. So we're going to find all that info. This is all they've given us. Okay. In any triangle, you technically need 3 pieces of information to solve for the rest. And it looks like we only have 2. It looks like we have 50 and 6.
But you know that's 90.
Yes, but we know that's 90, exactly. So we do actually have 3 pieces. They just kind of tend to neglect it when we're using primary trig ratios. As you get into non-right angle triangles, it becomes very prevalent when you use like sine and cosine law. Okay, so let's start with x. Okay, first goal is we're going to try to solve for x. So in other words, we obviously have to use the 2 pieces of information we have, and we need to try to solve x. So we're going to set up all 3. And we're going to see which ones include the 3 pieces of information that we actually have. So, so is sine 50. 50 is our theta. So sine 50 is equal to the opposite. Well, the opposite is 6. And the hypotenuse is x. That looks pretty good. That looks like what we got. Let's try next. Cosine 50 is equal to the adjacent, which is y. And the hypotenuse is x. No, we don't have enough information. You can only have one variable in an equation or in one equation and still be able to solve it. And finally, tan. Tan 50 is opposite, which is 6, over adjacent, which is y. Okay, we can solve for y, but our goal was to solve for x. So it looks like this is the formula we're going to use. As you get better and better at doing this, you'll start to realize, and for the next few I'll do that, is that you'll go, okay, looking for the opposite in the hypotenuse, that's fine. And I know just to set that one up, okay? But if you're unsure, you can set up all 3 and kind of just choose from the ones you want. So now that we know that, sine 50, well, it's really just isolating. So sine 50 is equal to 6 over x. We need to get x by itself. So because it's division on this side, when we move it over, it'll become multiplication. So you'll have x times sine 50. So I'll write it out again. You'll have x times sine 50. And sine 50, when you put in your calculator, will be some value. We're just going to not do any calculating until the very, very end. We're still isolating for x. So now to move sine 50 to the other side, we have to divide by it. So now we're left with x is equal to 6 over sine 50. And that's something we can put into a calculator. I think mine works in degrees. Hoping it's in degrees. Maybe there's some kind of preferences here. Let me check. Okay, it says I'm in degrees. Let's see if this works. Didn't always work. 6 divided by sine 50. I don't know if you guys have a calculator. I'm going to check with. Tells me that is side 7 is 7.83. That seems logical. Yeah, 7.83 approximately. And you can always try to make sense of stuff. If this is the hypotenuse and we're saying it's 7.83, that probably makes sense because it's going to be the longest side and it's longer than 6, so that makes some sense. So on the assumption that this is correct, we now have more information. Okay. Next, let's solve for y. Well, luckily, we already set up our ratios. If we look below, we can use tan to do that, right? Tan has just y in it, so we can use that information to go for it. Now that we actually got more information, we could have filled in 7.83 here and now used cos because we have more information. But right off the bat with the original stuff, we'd have to use tan to solve for y. Okay, so as you get more info, it opens up more possibilities for formulas. Okay, so tan 50. Same idea. Tan 50 equals 6 over y. As you can see, the pattern here is to pretty much just interchange this tan 50 and the y, so I'm going to do that. Y is equal to 6 over tan 50. And if you're kind of unsure, just kind of look back to that note on how we did that. 6 over tan 50, which means y is equal to, and same thing, I'll put it in. I'll get my calculator out. I'm going to just change the sign to 10 and 5.03. Okay, that also makes sense. It looks like that is the shortest side, right? What do we say it was? 5.03?
5.03.
Yeah, 5.03. Makes sense. Okay, and finally Z. Now, technically we can find Z really, really easily. I know that's 90. I know that's 50. A triangle has to have 180.
So you subtract.
Subtract, it's telling me it's 40. 40 is going to be the answer there. But let's go on the assumption that they didn't give us this angle, okay? And now we only had sides. Okay, well now that's a little different. If I don't have that angle there and I need to find Z, I have to use my sides, which means I have to use one of these three. Now if I have all three sides, which we do have now, I can use any of the three because I have all of the possible values. Okay,
Yeah.
So now that it's Z, and since we've used sine and tan, I'm going to use cos, and I'm going to set up cos for this. So cos, here's our Z. Cos is the adjacent over the hypotenuse. So adjacent is now 6. Because we're talking about a different angle, the adjacent is now changed. And the hypotenuse is now 7.83. So we're going to set up our cos with that. So cos theta, or sorry, I shouldn't call it theta. It's called Z in this question. So cos Z is equal to the adjacent, which was 6, and the hypotenuse was 7.83. So the goal is to isolate Z here, which is a little different. Think of it like you're bringing cos to the other side, okay? And if I were to bring cos to the other side, it would kind of be like division, so it's going to look something like this. But you can't divide by cos. Cos is technically a very large formula, and it's on the bottom. If you remember your exponential rules, to take something from the bottom and put it on top, we have to change the power, so we use the inverse, cos.
Oh, that's when you because we read some of the things we had to use that.
Exactly. So anytime you're solving for an angle, that's when you use to the power of -1. Okay. So you're gonna whatever this ratio is, you get what this number is, and you put it into cos to the -1. And if you're working in degrees, make sure make sure you're working in degrees. So we set that up now. So Z, I'm gonna write out the equation, is equal to cos inverse of 6 divided by 7.83. So whatever that is, okay? So again, you can kind of put that all into your calculator. Usually it comes from second function. I believe it says a cos, but usually on your calculators it'll say to the power of -1. Okay? And then I just do 6 divided by 7.83. And actually, let's do this. This calculator is really neat where I can take old answers, boom, and put them in. There you go. And 40. And that's exactly what we said Z was going to equal in the end. It was going to be 40 degrees. So we went through all three, and we solved for sides and angles, and those are the only options. You either side for solve sides or angles, and use cos, tan, or what did I miss there? Sine to solve an angle, and use cos inverse, sine inverse, or tan inverse to solve for an angle. Okay? Does that make sense?
Yes.
Yes.